So very good evening to one and all gathered here. Today we are going to see about replacement problem in operation research from unit number 2. So let us discuss the basic theoretical foundation for replacement problem. At the end of the theoretical foundation, we are going to see about a simple quantitative model and a replacement problem. And the further continuation we will see in the next segment of the online presentation. Today we will gather some of the few outlines about the replacement model, how that is closely connected with the management, applied management science, operation research. Let us understand the topic purpose and the primary goal, why the replacement model, the concept is studied under operation research. The primary purpose of replacement problem is to discuss about the optimal replacement strategy of a machine or equipment that may degrade over a particular period of time, or it may fail suddenly due to the continuous usage under periodical basis. So replacement model deals with maintenance and operating aspects of the machines, tools as well as the equipments. Next, what is the goal of replacement model? The primary goal is to estimate the most economical replacement policy. When, at what time we have to go for the replacement of a faulty component by keeping a new one instead of a old failure component with the better continued operation and maintenance aspects. So with this few outline, we will go to the chapter introduction about the replacement problem. You take any manufacturing industries in today's scenario, all manufacturing industries comprises of equipments and large machineries that are put under continuous usage of production. Over a period of time, the internal parts of the machines may get wear and tear, and that will lead to further reduction of mechanical efficiency of the equipment due to the continuous usage purpose. The study of replacement mainly focused on the certain situation, such as, say, the particular mission component which may fail suddenly or gradually. So, what should be the maintenance strategy we have to take? Either we have to go for a group replacement policy or an individual replacement policy, depending upon the time circumstances. So next one, the deteriorating efficiency is nothing but the complete breakdown of a machine. So this complete breakdown event may happen due to gradually slow failure or sometimes due to sudden impact failure. So this depends upon the seriousness of the situation. What are the various types of replacement problem that are found in the existing literature? There are three classifications. The first one is replacement of items that deteriorate with respect to time as a major concern. Second type of problem, replacement of items that may break down completely due to sudden failure. Third, the replacement of items that becomes outdated due to new technological influence. So these are the three different the category we have to consider the exchange of new items by pulling out the old defective items in the machine or equipments. Now let us see a numerical case study to understand the basic concept of the replacement model, the theoretical fundamentals. Here we are going to see about replacement policy when value of money does not change with respect to time. So what is the main objective of this model? Here we have to find out the optimum replacement age of the equipment when the maintenance cost is supposed to increase with respect to time, but the value of the money remains static during that period. Let us see how this objective can be better understood with a simple numerical illustrative problem. Let us take this problem. For instance, the firm is considering replacement of a asset or machinery. The buying price of the asset is said to be 12,200 rupees, and the scrap value, that is resale value of the asset, is rupees 200. The running costs are found as according to the experience as follows. Running cost is nothing but maintenance and operating cost of the machine. So totally 8 years it has been scheduled. For every year, they have given the individual operating maintenance cost and the table. So here what they have asked, when should the machine should be replaced? So totally 8 years the available year. Out of this 8 years, in which year the machine has to be replaced due to the aging effect, failure, and other mechanical problems. That is what asked in the given question. So the given data as described here below. So from the above problem, so we have the following information: the maintenance or running cost, scrap value, and the cost of the machine. So by using this information, we have to find out the optimal time when the machine has to be replaced. First of all, for that, we need to find out the average total cost per year. For 8 years, we have to find out the individual average total cost during the entire lifetime of the machine. So this comes in the following, the next slide. So the table has been drawn in this format. In the first column, the number of years ranging from n is equal to 1 to 8. The running cost or maintenance cost function. Say for the first year, it is given as rupees 200. Likewise, for the second and third year, 500 and 800 rupees. For the fourth year, 1200. Fifth year, 1800 rupees. And for the sixth year, 2500. For the seventh year, 3200. And for the last year, it is found to be 4000 rupees. So these are the individual running cost function, that is maintenance cost, for the corresponding years as listed in the table. Next one, using this data, we have to find out the cumulative running cost function in the third column. Say for the first year alone, the cumulative cost remains same. So same value. For the second year onwards, we have to add the cumulative cost of the previous year with the next consecutive year. Say 200 plus 500, 700 rupees. That is the cumulative maintenance cost for the second year. Similarly, for the third year, 1500, that is 7000 plus 8000. So for the fourth year, it is calculated to be 2700. How? 1500 plus 1200. Then for the fifth year, the cumulative maintenance cost 4500. By adding 2700 plus 1800, you will get this value. For the sixth year, 7000 is the cumulative maintenance cost. So we have to work out in the same way. The cumulative cost for the fifth year, 4500 plus maintenance cost for the sixth year, 2500. So you will get 7000. Same for the seventh year, 10,200 rupees. 14,200 rupees for the eighth year. Okay. So by adding 7,000 plus 3,200, you will get 10,200. 10,200 plus 4,000, 14,200 rupees. So this is the way to work out the cumulative running cost. Next one is depreciation cost. So we know the formula depreciation. capital cost of the machine minus the scrap value of the machine. So from the given data, the capital cost of the machine C is equal to rupees 12,200. The scrap value rupees 200. So you have to subtract these two values. 12,200 minus 200. So you will get 12,000 as the depreciable amount for the first year. So this amount will be maintained constant throughout the 8 year. So 12,000 rupees equally. Okay. The next one, you have to find out the total cost by considering cumulative running cost plus depreciation cost. Adding column 3 and column 4. Put this value in the column 5. So 200 plus 12,000, 12,200. So 700 plus 12,000, 12,700. So likewise, we have to do the calculation for the rest of the year, the corresponding rows. Last one is the average total cost. So this is the main ultimate thing we have to find out. So how to calculate the average total cost? So previous column number 5 divided by column number 1. The column number 1 list out the number of available years. So we know the total cost. So column 5 divided by column 1. So this is the sixth column in which we have to find out the average total cost. So let us see sample calculation. 12,200 divided by the first year 1. So the same value you will get average total cost. Let us see for the second year 12,700 divided by 2. 6,350 rupees. So this is the average total cost for the second year. Then for the third year, it is keep on decreasing to the smaller value. So you can see the pattern. Earlier, it is 12,200. So you see the second year, there is a slight decrease. So when you go down to the next consecutive year, so the pattern of average total cost keeps on decreasing to the minimum value. Okay, so 3,167, 3,300, 3,167. Then for the seventh year, you can see there is a sudden hike in the average total cost, 3,171. So here we have to find out the minimum average total cost out of the 8 years, available 8 years. So sixth year, so the minimum average total cost was found in the sixth year, end of the sixth year. So 3,167 rupees. Okay. So this is the better time period for replacing the asset. So once in every 6 years, we have to replace the failure part of the mission by keeping the new spare one. You can see the inference below the table. So we can see that the average total cost is found to be minimum at the end of the sixth year. And then from the seventh year onwards, there is a slight increase. Hence, we have to take a final decision to replace the mission at the end of the sixth year, where the value of the average total cost is found to be very far minimum value. So this is the method to find out the replacement model of a particular asset as given here. So with this few introduction, so we will see the remaining segment in the next online presentation. Till then, thank you one and all.